Hello everyone and welcome back. My name is Mr. Covalt, and in this video we're going to figure out what the activation energy is for a reverse reaction given the activation energy and the change in energy of the forward reaction. So let's get into this. Okay, so in this problem we're told the activation energy for the reaction NO2 gas plus CO gas gives us NO gas plus CO2 gas is 125 kilojoules per mole, and the change in energy for the reaction is a minus 216 kilojoules per mole. What is the activation energy for the reverse reaction shown below? And they're giving us the reverse of this reaction. So instead of having the products here, we have them as reactants, so NO gas plus CO2 gas. And then that's going to give rise to these, which are the reactants over here, but now they're products. So basically, that's the reverse reaction. And so they want us to explain what the activation energy is. So what we're going to need to do is write a reaction diagram. And so the first thing we need to know is whether this is an exothermic or endothermic reaction. And that's going to come from the delta E. And you'll notice that the delta E for the reaction here is a negative 216 kilojoules, right? So this is the reaction that we're given. So let's write the reaction diagram or energy diagram for this reaction. So since the delta E is negative, that tells us, and we're looking at this reaction right here, that tells us that we have given off energy. Energy has been released. And so what does that tell us about the relative energy of products and reactants? Well, if we're giving off energy in the process of the reaction, so that means that we're losing energy as we're making products. So that means that the energy at the end of the reaction is lower, and therefore the products must have lower energy than what we started with in the reactants. So that means the reactants must have higher energy and the products must have lower energy. So when we write our diagram here, so we'll have the reactants up here, right? So let's write the reactants here. So we have NO2 gas. So here we have NO2 gas plus CO gas. Okay. And so that means down here we'll have our products because the products are lower in energy. And so we'll write the products NO gas plus CO2 gas. Okay, so when we draw the curve, we have an activation energy. So activation energy is the energy that's needed to overcome the barrier for reaction, right? So that's basically the energy needed to break bonds, to form new bonds. And so it usually looks something like this. Let me use a different color marker. So if we here, let me write these below the lines so that'll be better. So we have, oops, let me use black again. So NO2 gas plus CO gas. And let me put this below the line too. So we'll put, the products are NO gas plus CO2 gas. And so when I draw the curve, the energy is going to goes up and then comes down like that. So, so here, let me use a different marker. And so here, from here to here, that's the activation energy. And we're told that that's equal to 125 kilojoules per mole. And so what about this delta E? Well, the delta E is the difference in energy between products and reactants. So that's the energy here. So between these two, between this level here and this level here, this here, that is delta E. So the difference in energy between products and reactants is the change in energy of the reaction, and the distance from the reactants, the energy that the reactants have, up to what is called the transition point or transition state, which is at the top of the hill here. This is the activation energy. So this is the energy that has to be overcome in order to get the reaction to go, or in order for bonds to break and form, new bonds to form. So now we've got it set up for the forward reaction. So if we go in the opposite direction, then basically we're starting here as reactants, and we're going to go up to here in products. So let me change it. So this should be, so the delta E here is negative. But if you look at the picture, we would have to go this way. So we would have to go this way in order for these to react and form products. So now we got these as the reactants and these as the products. So you can see right away that you would have to go up here. And so now they're asking, what is the activation energy for the reverse reaction? Well, remember, again, the activation energy is the hill that has to be overcome in order for the reaction to go. Well, here's the hill for the forward reaction. But notice now the hill for the reverse reaction is this up to here. So it's from this level to up to here, and you can see that it must be then the delta E that we have plus the activation energy of the forward reaction. So these two added together would be the activation of the reverse reaction. So if we put that together, then we have the activation energy for the reverse, R for reverse, and we'll call this the forward. So the activation energy of the forward. So the activation energy of the reverse is going to be the activation energy of the forward reaction plus delta E. Okay, and in this case, delta E is going to be positive, right? Because we're going in the opposite direction, so therefore we're gaining energy. We're going to absorb energy going from here to here, so the delta E is positive, not negative. So then we end up getting that is equal to 125 kilojoules per mole plus the, where is it? The positive 216, not negative, positive 216 kilojoules per mole. And so add that together and you get 341 kilojoules per mole. Let me double check. So 3 and 11, yeah. So that, ladies and gentlemen, is going to be the activation energy for the reverse reaction. I hope that was helpful. I hope that was clear. If you enjoyed the video, or if this video helped in any way, then please, by all means, like the video, share the video, hit that like button somewhere over here You can find it. I believe in you. Also, do me a favor, subscribe to the channel, hit that notification bell. When you do that, click all so you can be notified by all the videos I put out. And finally, put a comment down below in the comment section. Let me know what you think. Ask me questions. I would love to hear from you. Thanks for joining me. Have a great day.